Welcome, Sim Horizon viewers. Rob Ainscow here, software engineer and owner of Sim Horizon. This is part 3 of my 3-part series, the final installation of my silent chiller unit here, and I'm happy to report this prototype is now complete. The big giant extension you see on top there are actually the heat exhaust tubes. This is an optional component. It's not a required component, but if it's for those customers that would like to have the heat routed elsewhere, be it in a spare room or a different part of the house or building or wherever you want to route the heat, especially if you live in a cold climate, you might want to route this heat into a room so you can save yourself on a heating bill. If you'd like to see the version without it, check out this picture here. Let's go ahead and take a look inside of this unit and see what's going on. We have a nice keyed door here, which is sound insulated. There are, of course, some holes for venting, or I should say to allow fresh air to come into the unit, which is then exhausted through these fans up here outside of the unit. And the hot air is going to come from the vapor chiller here. These two fans will be blowing out fairly significantly hot air from the vapor chiller, which is this unit here. And all the electronics are in the back here. That's the control unit, live circuit that I put together with an internal temperature sensor here that will monitor the internal case temperature and adjust the fan flow up here to make sure that the case is sufficiently cooled. You don't want it to get too hot in here, otherwise you start losing efficiency on your cooling. And the pumps are in the back here. These are 2 pumps, as you can see from my other video. Probably get a better idea of what those pumps look like. And this unit is, you can detach these side panels here. They just come out through these clips here. You can pull them out. And again, side panel is sound insulated. So you have good access. You can do this from either side. So it's easy to access anything that needs to be checked, updated, or monitored, or if you need to refill the system or add liquid to the system. It just clips back in. And as you can see here, the unit is on wheels. And that's important. It needs to be at least on wheels or on a stand. This is a single vapor chiller, so it's not too terribly heavy, but there's an option to add a second one of these over here, and that will increase the weight considerably. Unfortunately, the other components will be able to use that additional chiller if needed. But this has about 450 watts of chilling capacity running below ambient. If you need more than that, like I said, you can add a second one. You get up to 900 watts of cooling capacity running below ambient. Control box in here and how I've programmed that, and that will ensure that there is no condensation on the unit, which is a big problem. So I manage condensation through the various temperature sensors and coolant sensors. If we go to the back here, you can see I've got some additional ports here. One of those ports is the temperature sensor, which is this one. This is a 3-DIN plug, and you can see there, that plugs into here, which then allows you to run this wire, which goes to external temperature sensor. Now, this temperature sensor, you can have a 10-foot wire, 20-foot, 30-foot, however long you want. When the unit is being purchased, specification of this wire will be part of the purchase, and that can be up to 30, 40, 50 feet away, wherever you want this to monitor the temperature, because this is, and humidity, because this is what's going to be the primary sensor for driving or checking to make sure that the condensation doesn't happen, and make sure you don't drop below a dew point in the actual cooling lines over here. So this can be located anywhere. It can be close to the unit, or it could be in a separate room, wherever you want it to be. As I've mentioned before, this is a USB port. This is actually connected to my laptop right now. I can do additional programming through this port to make final adjustments to, say, the pump speed, or pump speed, I should say. There's 2 pumps in here. I can also adjust the fan output from the case. I can make adjustments to how much the vapor chiller is going to be cooling. So there's a lot of things I can do through this USB port here, which has a cap for it when not in use. Same with the temperature sensor port. There's a cap for it when not in use. This is a standard US plug here, PC computer plug. So 110 to 120 volt US. I can put in any plug type that is needed for different countries, UK or Japan or wherever the country is. I can easily install a specific power inlet for that particular country. Again, that'll be specified when the unit is purchased. The way this works is you just plug it in, you'll get a green light showing that you actually have power. This is the power switch, but the light being green is just telling you you've got power to the unit, not that the unit is currently on. So before we turn the power unit on, I have a sound meter here. I'll be quiet so you can get a basic room noise level. Okay, so we're looking at somewhere around 36.8 dB. So let's go ahead and turn the unit on. Now it's going to be a little bit of ramp up time as the pumps get going. Okay, so it's around 49 dB. That's with the vapor chiller running and trying to cool the unit right now. That's with the fans running also, and with the top fans both running. All right, so let's open up the unit here. Go back in, see what we've got going on in here. We've got current water temperature at 66 degrees Fahrenheit, and the pump rate is around 260 liters per hour. Let's go ahead and close this, because that will go down to whatever the ambient reading is. These are the top vent fans. There's 2 fans in here. They're 120 millimeter fans. They can run up to about 2300 RPM, but they won't run too high when the temperature inside the case is not hot enough. They'll be completely automated and managed by my control unit. And here's the output from one of those fans. This is going through a 25-foot duct. You can feel the air coming out through here. And that goes all the way up to the unit up there. Again, you can run 2 of these. You can have different lengths. It's entirely up to what you need or don't need. I have the unit currently connected to my laptop here. I'm going to go ahead. This is my code up here. I'm going to bring up what they call a serial monitor, which will kick in. It'll actually reset the logic unit and start it from scratch. Let's go zoom this up. And here we're going to see actual values from inside the unit and external values. It'll have coolant temperature, the dew point, both internal and external. Temperature inside the unit is over here. As you can see, it's 73 degrees inside the case, and the external temperature is 66 degrees. And if we go over here, you can see our humidity levels, internal and external humidity levels. And then the actual coolant temperature here, that's going to drop down to what's the dew point to external, which is at 49, and coolant temperature is 54. So that'll drop down to around 50 degrees Fahrenheit to make sure it stays above the dew point for the external sensor over here. And that'll ensure that we don't get any condensation. This is all handled automatically, and I can use my laptop here or another computer actually, or even a remote computer to make any adjustments to the code and update the firmware as necessary. Now, as I said before, I've got the actual coolant water block here is connected up to, which is really just a test block I have. It's not connected to anything. And that I just used as a test. So what I'm going to do is actually connect this unit up to a computer and do some actual real testing. All right, so the silent chiller is now hooked up. This is in my garage, and it is now connected to my computer. My computer actually isn't running yet, but I'm not going to get deep into that right now. But here's the unit. There's the exhaust vent that goes all the way out. That could be connected to a heater, or could go outdoors, wherever it needs to be done. And here's the tubing. This is there's about 38 feet total in the loop here, and the tubing goes long and runs into the PC here. And if we go around the side, you can see it coming in through the bottom there. The top tubing is the hot side. The bottom tubing is the cold side. So the cold side comes in through here, and then it goes directly into the CPU over here. And then the CPU goes out to the VRM, and the VRM goes out into the RAM, and then the RAM returns into the return line. It goes down here and out the back to the silent chiller over here. It can actually go further than 38 feet of tubing. Most of them, according to my calculations, you could probably push it all the way up to 50 feet, maybe even more. And as we can see in here, we'll take a look. And we have flow rate has dropped just a little bit, which is expected for this much tubing and going through quick disconnects and going through a computer. So it's gone down from about 270 to 280-ish down to 225, which is still plenty of flow. Temperature is 51 for the water, or I should say for the coolant. Okay, so I have a temperature probe sitting on the CPU block, and I have a temperature reading here of about 55.9 to 56, which is, we're in my garage here. The dew point is right around 53, I believe, 54. So we're not going to get much colder than this. Now remember, this is external temperature sensor on the CPU block. The temperature sensor in the actual silent chiller here is is taking the temperature reading of the actual coolant, not an external reading like I'm doing here. So the coolant will be a little bit colder. I would expect probably going to lose about maybe a degree, possibly at most 2 degrees Fahrenheit over the long distance of the tubing here. This is a thermal image camera I have on the heat exhaust from the silent chiller. And as you can see here, it's the hot part is around 76 degrees Fahrenheit, and that's just exhausting the hot air generated from the vapor chiller inside the silent chiller. And this is not, obviously, this is an image, thermal image, so it's not going to be 100% accurate, but it's going to be pretty close for my needs here. I can also verify these temperatures through my internal logic. There's a temperature inside there as well, which monitors that and adjusts the fan speed accordingly. And here we are on the CPU side, just doing another external image check on the temperatures of the CPU block. As you can see, it's running pretty close to what we had on the actual physical sensor, maybe a couple of degrees here and there. And here's the cooling tubes. Obviously, they're a lot cooler. And inside we have our vapor chiller and the power supply. That is probably the power supply heat we see there, which is 78 degrees Fahrenheit. Okay, I'm gonna do a quick recording of the noise level. Obviously, you hear my voice there, so it's showing up in the dB readings. Get an idea of what it would sound like from my desk if I had the computer over in this location and the chiller behind me. Bear in mind, I'm in a high echoey garage here, so there's gonna be a lot of echo happening. But in a house with carpeting or with sound insulation in the walls and stuff, it would be an even lower reading. So with that said, let me shut up and let's get a dB reading here. Okay, so under load, it's about 42 dB, which is pretty close to where I wanted it to be. I was hoping for about 40 dB, but that's not bad, especially considering I'm in a garage here. And to wrap this video up, I'm going to go ahead and disconnect these tubings. You might think, oh man, it's going to be a mess to move these things around separately, but they have quick disconnects. Which just pop out, and then pop these out here. There we go. And you see, no coolant, no coolant. Same with this one down here, same thing. No coolant leaks. And I'll go over here on the other side. And I'll do the same thing. Pop, no coolant leaks, and pop, no coolant leaks. And then I have these little caps I put on the end of the tubes here. They protect them from any damage. Go ahead and put one in each tube. And they also have caps I can put on the end of the female side of this. On the quick disconnects there. There you have it, and that's, let me go over here. Caps on here, and more caps on here. And that's it. Here's all my tubing. Let me coil that around. So you can have this tubing as long as you want, and you can quickly disconnect the two units. And then you can go ahead and move this around, and as you can see here, all my coolant is still there. And same with the chiller. I can then move the chiller around to wherever I want to move it. So it's very expandable, versatile, easy to move things around. So that concludes part 3 of this 3-part series on the silent chiller. I'm looking to get some investors now, and also looking into possibly making a couple of more for YouTube reviewers to take a look at and review and see what they think of these. Thank you for watching.